So let us look at case 5 and the last case in the resolution of vector. Don't forget, we're still talking about vectors. Case 5, we have done case 1, 2, 3, 4, and now let's do case 5. And say case 5 is when the two vectors act at obtuse angle to each other, which is angle greater than 90 degrees. So angle when theta is greater than 90 degrees, but less than, of course, 180 degrees. So let's see this. It means that if we have an horizontal vector like this, and the other one should be in this way. So you can see this is supposedly 90 degrees, so it must be bigger than 90 degrees. So let's have, this is a 30 Newton vector and this is a 40 Newton vector. So have something like this. Theta is, what do we choose? 120 degrees. So let's say theta here is 120 degrees. So if theta is 120 degrees, what do you do? Remember we said we can use our scale method as well, and we can still use analytical. So for scale method, what do we do? Choose your scale first. 1 cm is 10 Newton, which means here is going to be 3 cm. Here is going to be 4 cm as usual. So which means, remember how you used to draw your horizontal line first, then mark out any point, put your protractor there, then from here trace, you have your 120 somewhere around here, put a point there, then draw a line to join this point and this point like this. So after drawing that, you can now mark out your 3 cm from here, then come here, mark out your 4 centimeters on this line as well. So you have marked out your 4 centimeters. And at this point where you mark out your 4 centimeters, put your protractor there again. Then from here, count your 0 and come somewhere around here is your 120 degrees again. Rule a line there as well to join these together like this. Then on this line you have ruled out, mark out your 3 centimeters. Do not forget, mark out your 3 centimeters at that point. And then after marking out your 3 centimeters, join this to this. So this is a typical case. Then on this point, of course, this is your 120 degrees. Don't forget, here is your 120 degrees. So draw your diagonal line from here to here. Don't forget, this is your resultant vector now. So having drawn that, you now use your ruler to measure here. Whatever you get is your resultant vector. So this is 3 cm, don't forget. This is 4 cm. This is also 3 cm. This is 4 cm as usual. So this is how to solve your analytical method. So while looking for your direction, put your angle here. So when you put your angle there, then put back your protractor at this point, then measure from here to here. What angle is here where you have your R? That becomes your direction, which is alpha. Okay, so that is also done for that. Then analytical method. Of course, you have to use formulas on this. Remember, our force is this, so this is 40 Newton, this is 30 Newton. So here you have 120 degrees. Now, as usual, just use your line to join this, and then draw this. So here it becomes your R. Okay, so let's solve. Remember, we're using our cosine rule. So from cosine rule, R squared is equal to 40 squared plus 30 squared minus 2 times 40 times 30, then cos theta here now is 120 degrees. Don't forget that, 120 degrees, which is the angle theta here. Okay, so you solve. R squared now is equal to, here is 16 plus here is 900 minus here is 1400, then cos 120.5, so minus 0.5, so you have to minus times minus is plus. Well, let's see, 2500 here plus 0.5 times no, here is 2400, sorry, 2400. So 0 times 5 times 2,400. That's 1,200. So plus 1,200. So that gives us r squared is equal to, this will give us 2,000. Okay, sorry. This will give us 3,700. So r now is equal to the square root of 3,700, 60.8 Newton. Then how do we find our direction here, alpha? Remember, this place is 120. Yes, this is 120. So if this is 120 and the whole of this is 180, so what will be here? Here will be 60 degrees, I guess. So let's take this triangle out. So we have a triangle like this. So this is our triangle now. So this is 60 degrees. This one is alpha now. This is our resultant vector. This is our 30 Newton. This is 40 Newton. So we have two angles here, this and the line opposite it, this and the line opposite it. Now, to solve that, we have sine rule. Don't forget, you have to use your sine rule. So A over sine A is equal to B over sine B. So that gives us A here, we can liken it to be 30 Newton, and then B, the angle is sine alpha is equal to B. We can liken it to R, and remember R is 60.8 over sine angle opposite it is 60 degrees. So that gives us, cross multiply, you'll be having 60.8 sine alpha is equal to 30 sine 60 degrees. So sine alpha now is equal to 25.98 here, all over. Take this one to this side, that becomes 60.8 will give us 0.4273. So we have alpha is equal to sine inverse of 0.4273, and that gives us alpha equal to 3 degrees. So that becomes our answer. I hope you got it properly. Please do not forget to subscribe to our YouTube channel for more lessons.